So without further ado, I would like to introduce you our first speaker, Ishika Tailor. Ishika, could you turn on your camera?
Yes, sir.
Okay, all right. So, Ishika today, Ishika will present her research on fish and tracking and recognition, and this research uses heuristic method and neural networks to train models for identifying fish from the video feed. So let's welcome Ishika.
Yes, sir. Let me share my screen first.
Yes.
Okay. So first of all, thank you so much for taking out your precious time to see my presentation. My name is Ishika Tailor, and my project name is the Adaptive Ecological Farming, the Fish Recognition and the Tracking. So the main research goal of this project is to identify the fish. The main goal of this project is to detect and identify each fish uniquely. We have one webcam which is connected to the fish tank and which is capturing the video time to time. So our task is to identify the fish movement pattern, the way the fish are moving into the tank, and as per the fish movement pattern, we are training our model to detect the individual fish. So this is the summary of our research goal. So basically the whole project is mainly divided into the two stages. So the first stage is the fish identification, and the second stage is the fish tracking. So we will see first the stage one. Now in the stage one, there is mainly the four tasks: the frame and the boundary box extraction, assigning the UID of for the boundary box of the fish, and then the third one is the web UI for showing and altering the boxes and dashboard of the progress behind the scene. So let us see the individual tasks first. Okay, so let us see the workflow of the stage one. So we have one webcam which is connected to the fish tank, which is capturing the 30 to 40-second video. Now, after capturing the video, we are uploading the video onto the server. Now after uploading to the server, on the backend there are the Python script are running. Now the first Python script is the frame extraction. So what it is doing is it is checking that whether there is any new video uploaded or not. If there is any new video is uploaded, then it will be just simply convert our videos into frames. So let us suppose that 1, 2, 3, and it is the frames of that video, and frames are converted as per the FPS rate. Now, after converting the videos into the frames, the next task is to identify the boxes over the fishes. So the boundary box script will be run. The second script is the boundary box script, which is running in the backend, which is detecting the fish which is detecting it is taking one by one frame, and it is detecting the whether there is any fish present or not. If there is any fish, then it will be just simply throw the boundary box over it. Now, after going onto the each frame and detecting the fish onto the each frame, the next task is to assign the unique ID so that we can identify the each fish uniquely. So the third script is to assign the unique ID. So let us suppose that we have the two frame. Now onto the two frame, we have one fish is onto the left hand side. Now onto the second frame, the same fish is also present onto the left hand side, but nearly some distance will be present between the two boxes. So what we are doing is we are calculating that whether if there is a distance between the two boundary boxes which is present onto the different frame, which is less than some variable, let us say 50, then we are assigning the same UID to the each fish. We will see later how it is working. This is a basic progress how we can assign the unique ID. After assigning the unique ID, we have one final CSV file will be created, which is containing the frame number, XY coordinate of the boxes, UID of that box, and the file name. And this CSV file will be uploaded to the server. And after uploading to the server, we can analyze the each frame. On each frame, we can analyze the each fish also. And also each unique, for different UID, there are the different color is also assigned, so we can easily observe the each unique ID individually. So this is a basic workflow of the stage one. Now let us see how the frame and boundary box extraction is working. So for the boundary box extraction, there is a two method, by the label image software, and the second is the YOLO v3 model. So after uploading to the choose file, we have to just select the file and it will be automatically uploaded to the server. And the first is the frame extraction will be run. So the frame will be it will be take the video and it will be just converted our full video into the frame. There is a frame folder which is created and it will be storing all the frame like the file, the video file name and the image file name. Here the image 0-t, it represents that the image number 0 at 0 second of the video. The image number 1, which is at the 0.05 second of the video. So as per the FPS rate, all the images will be created. And on the database, there is a frame extraction table is created, and it is whenever the frame are creating, there is an entry will also be created onto the database of that file name with height FPS of that video. So after converting to the frame, now the method one is by the label image software to detect the boundary box of the fishes. So this is the basic snapshot of the label image software. We can just load our whole image directory on this software, and we can create a manually boundary box over the fishes. Now, whenever we are creating over the fishes, there is a .xml file will be created, and this .xml file we can convert it later into .csv format, and we will get the CSV file like this: the file name, height, width, the boundary box of the coordinate. So after combining all the XML file into one CSV file, we have one final CSV file we created. But this creation of the boundary box we are doing manually, which is very time consuming, because for the each frame we don't have time to go to the each frame to draw the boundary boxes. So what is the second method is? The second method is to YOLO v3 model. So we are using the YOLO v3 model. We are passing some amount of the data set to train our model. And then later, if we pass new video to the model, then it will be automatically detect the fish. So here we can see that the model structure, and this is the YOLO format data set I have used. I have used .txt file, which is present in the YOLO format, which is also created by the label image software. And this .txt format content like this: the 50 is the fish ID, and this is the boundary box coordinate. And I have trained YOLO model for the 6000 epoch. And by running this darknet command, as you can see on the right side, I have just uploaded one sample image 001.jpg, and it is detecting the fish with accuracy. For example, the fish 100%, fish 86%, 1, 2, 3, 4, 5 fishes are detected with the accuracy of the nearly 100%. Now after running the YOLO v3 model, we have one final weight file will be generated, and this weight file will be used by our boundary box Python script, which is detecting the fish, and it will be also append all the boxes onto the boxes variable, and it will be just draw the rectangle over the each frame. So let us see the output of the video of our YOLO v3 model. So as you can see that I have uploaded one sample video, and the YOLO v3 model is detecting the green boxes, which is detected the fish over the boxes. And sometimes it may not be detected just because of the water noise or some other parameter. But as far we can see that the boundary box of we can perfectly detecting the boundary box over the fishes. So the second task is completed to detecting the boundary boxes. Now, also, whenever we are detecting the boundary boxes, the script is also updating the database that how many frames are completed for the boundary boxes. For example, we have uploaded the last video 125.mp4. Then this video it will be updated database that 614, means that 614 frames are done for the processing of the detection of the frame, and 30 seconds of the video is completed for the boundary box detection. Whenever it will be completed for the boundary box detection for the video, then it will also update the database that it will update the database completed status. Now Let us see the accuracy of our YOLO v3 model. What is the accuracy we are getting? So we are using the library darknet and OpenCV library. Dataset generation is used by the label image software. Now to train on the one video. So previously I have trained onto the one video. Uh, just a second. Okay. So previously I have trained onto the one video, and I have passed 150 data set to the YOLO with model, and we can observe that for the new video, which is newly for the YOLO v3 model, it is hardly detecting the one boundary box over the fishes. Now when I now so what we can do is we can pass so different kind of the video, different kind of the data set. So and later I have passed five 586 images to the data set, and the accuracy I have got is the 80%. So we can see that the boundary box of the green boxes are detected more compared to the left one. Now, how we can analyze the accuracy model? So the more IOU value, the more mean average precision, the better our YOLO v3 model. So on the left hand side, we can see that it is nearly the 69%. Now on the right hand side, we can see that we have already increased our YOLO v3 model accuracy by the 80%. So currently we are using this 6000 epoch weight file for the detection of the fishes onto the video. Now, after detecting the fishes over the video, the next task is to assign the unique ID. So this is the UID function, which will give us the unique ID, the random color generation, which give us the unique random color. And now this is the main script. What it is doing is it is just comparing the two correspond frame. Now on this two correspond frame, suppose one frame and two frame. Now onto the one frame and two frame, if the it is taking the boundary box coordinate x min, y min, and x min, y min, and just getting the distance between the two coordinate of the two different frame. So if the distance between the two boundary boxes are less than minimum, let us say the 50. If the distance between the two boxes are less than 50, then we are assigning the same UID to the both boxes and color also. So after assigning the unique ID, we have one final CSV file will be created, which is containing the unique ID and correspond to color, image file name, height, width, and the frame number. And this whole dataset will be used by our web UI for showing and altering the boundary boxes. Now let us see how we can analyze the boundary box of the different frame. So yes, so we can see that in the drop down menu, we can see that there are some videos are already uploaded. I have uploaded 14 video till now. Now let us see the second video. Now onto the second video, we can see that this is the file name and image number. Now we can see that here the image number 1 T 0.05 second frame. Here the image number 2 0.1 second frame. And also there are the boundary box are created, and also correspond UID and color is also assigned. Now as we move on, as we just go on, we can see that all the boundary box and the UID is also assigned. Now if we want to change the UID of the some of the fish, suppose that this UID is not correctly assigned, because previously it was 97EC, but here it is detecting 0098. So what we can do is we can just click onto the box, and then one pop-up will be displayed, and then we have to just select the correct UID from the drop down list. So we have to just randomly we have to just as per our convenience, we can select our correct UID, and we have to just select, then we can see that the unique ID is also change, and the color is also change. And then it is also updating the database that yeah, this unique ID is not correctly assigned. Then it will also updating that previously it was this, now it is now this. And we can also go to the each frame, and we can analyze the unique ID of the each fish. If we found any default, any defect that no, this is not correctly assigned, then we can just simply click on and we can just select a particular correct UID from the drop down list. So in this way we can analyze and alter our boundary boxes for the each frame. Now the after assigning the correct UID to the old video, and also updating to the database with the correct UID. Now let us understand the dashboard of the progress behind the same. So before going on to the dashboard, let us understand the backend of the dashboard, how the backend is working. So onto the backend, mainly as I told you previously that there are the four main scripts are running. The boundary box assigning, it is generating the CSV format like this. Then pre-processing file will be just assign the correct image file name and frame number to the each row, and UID assign will assign the unique ID. Now on here we can see that the frame 0 are 5 times. It shows that onto the frame 0 there are the 5 boundary boxes are detected. Now on the right hand side, we can see that the bb underscore data, which is storing all the CSV file, and the frames folder, which is containing all the frames of the video. And this is the configuration file, and this is the weight file, which we have generated by the YOLO v3 model. And these all backend Python script are running daily. So also this daily, because this backend script is running as per the cron job. Each script will be start their work at the midnight, and it will be automatically terminated before the end of the day. If there is no new video, then it will be goes into sleep mode, and sleep mode. So basically, if I have assigned the time is 21 hours, so if on that day it will be time limit exists 21, then automatically all script will be terminated, and it will be start again on to the midnight 12 a.m. Now this is some basic question that how many frames we are supposed to extract from the video. So so we can on the dashboard, there is a progress bar for the frame extraction and the boundary box extraction. So on the frame extraction, we can just simply there are frame entries are also created, so we can count the frame entry and upon the total frames. So total frame entry will be done by the starting Python script. Whenever we are uploading the video, the starting Python script will automatically assign how many frames contain that video. So by the calculation of the total frame entry created and upon the total frame, we can analyze the progress bar of the frame extraction. And for the boundary box assigning, whenever the boundary box will be done, it will be also updating the database that how many counts it has completed. So by the sum of the count upon the total frame, we can analyze the progress of the boundary box assign. This is the main video table in which the name, location of the video, and SH1 code. Now, what is the SH1 code? SH1 code is assigned different for the each video. Suppose we have some similar kind of video, so we can't differentiate two video very quickly. So there is a SH1 code which will be identify the each video uniquely, the total frame, and this is the status of the frame boundary box preprocessing. Whenever the script will be done by this by their job, then it will be just update the database by the completed. Now let us see the demo video of the dashboard. So I have already recorded the demo video. So let us see. The date time of the video will be stored in this column. SH1 code will be assigned by the starting Python script. I hope my audio is visible for this recording.
Yep.
Okay, sir. The total frame will be also calculated by the starting Python script. The frame extraction, boundary box status, pre-processing, and UID status. If it is completed under the processing, then it will be completed, and if it is not completed, then the by default status is processing. The last one is the 22D underscore old, means that if the video file is 22 days old, then it will be automatically deleted. We will be see in deep later, but this is the basic summary of the video table. Now here, uh, we will see the how the progress is working. Let us see the demo video. So first we have to choose file and select one video and just hit upload video. It will be take some time and it will be upload the video to the server and also do entry onto the database. So let us see on the video table. Yeah, so the last row which is just recently uploaded and which is all are under the processing stage. The sh1 code and the total frame is also assigned. Now Let us see the boundary box progress table, in which we can analyze how many boundary box are already assigned. So yeah, we can see that train frames are done and 0.5 seconds are completed for the boundary box script. On the dashboard, we can also analyze that the 93% video processing are completed and 7% is remain for our newly uploaded video. Total 14 videos are present, and for the frame extraction converting it is 96%. For the boundary box assigning it is 93%. And if all the Python script will be run successfully, then automatically this progress bar will be increased and without reload, because in backend the AJAX call is running within for every 30 to 60 seconds. So we can see that the boundary box assignment is increased by 94%. Now after the AJAX call, yeah, we can see that the frame extraction is completed 100%. And also into the database, we can see that the frame status is also completed, which means that the video is successfully converted into all the frames as per the FPS rate. Now the boundary box assigning is increased 95%. Now it is increased by 96%, 97%, and so on till it will be increased by the 100%. So we can see that the frame extraction and boundary box progress both script are running successfully for all the videos are completed for this stage. So we can see that the frame status, boundary box status, preprocessing status are completed. Just the last stage is left, which is UUID status, which is 93% currently. So yeah, we can see that the UID's assignment is also 100% completed. And onto the dashboard, we can also see that all the stages are completed. And onto the boundary box progress, we can see that all the frames count are completed, all the 25-second video. Now our video's sh1 code is starting with D4. So here the D438 is our sh1 code. So here the D48, yeah, so here is the D48. All the three CSV files will be created correspond by the boundary box, preprocessing, and finally the UID assign script. So our dashboard is automatically whenever we are uploading the video, it will be automatically doing all the job, and we can also analyze all the process of all the script onto the dashboard. Now this is the delete image after 22 days. So if the video is 22 days old, then we are just comparing our current date time, and if it is 22-day old, then we are just simply deleting the frames from our OS system, and also deleting the entry onto the database. Now let us dive into the stage 2, which is the fish tracking. The fish tracking is containing the mainly 4 tasks: the movement extraction for the boundary box, web UI for showing and comparing the movement pattern, path detection model training, and path detection model outcome. So let us see the simple workflow of the stage 2. So after assigning the correct UID onto the web UI, if we found any wrong UID which is incorrectly assigned, then we have to just correct all the UID onto the web server. Then after assigning the correct UID, we have one final all images table database will be created. Now by using the database, there is a path image generator script is running, which is generating the dataset into 2 folders. The first is a marks dataset and path image dataset. Now this marks dataset is contain the dataset like marks black canvas images. Now this dataset will be used by our model to detect the path of the fishes. The model dataset is divided into train and test, and the path image model, which is trained for the detecting the fish movement pattern, and it will be just trained, and it will be save our model file into model folder, logs into logs folder, and model report classification report of the model into model report folder. Now this path image folder, and whenever we are generating path image generator, it is also doing the entry onto the marks table dataset. Now this dataset and path image folder, these both are used by the track UID web UI, which is so that we can analyze the movement pattern of the each fish, how the fish are moving onto the tank. So this is the basic summary of the stage 2. Basically, we are just creating the database, and we are just passing on to the model to identify the movement of the fish. So now if we have, first of all, let us say we have selected we have to select all the distinct UID from the database so that we can identify the for the each UID for the each different path. Suppose we have selected UID1. Now, if the UID1, if there is some small rows, small data, so some only three entries are created, then we are not taking it as a consideration for to create a path. Now we are creating the directory for the each UID, and this directory will be used by our model, and model will take this each UID as a classes, so that we are creating the directory, and each directory, suppose we have created directory 1 UID1. Now in UID1, whatever the images, whatever the movement path belongs to that UID1, the images belonging, the fishes belonging to UID1, the all images stored will be into that directory. Now here we can see that there is a UID underscore image file name, means that the image file will be created after the drawing the part, after drawing the movement part of the fish, and also the canvas image is also created, which is named by the underscore canvas, so that we can easily differentiate between the two images. Now after creating the canvases and the images, then the call event function will be called, which is just getting, we are appending all the coordinate of the boxes onto the points, and if the lengths are more than two, then we can simply draw the line over the images so that we can identify the movement. Now, yeah, so this is what I was saying, that we are creating the directory. This is the each unique ID, and each unique ID directory, it is consist the images belong to that UID. This is the marks image dataset, and this is the path image dataset. Two folder are created, which is this left side image folder will be used by our model, and the right is for our analysis purpose. Now, let us see the web UI for showing and comparing the movement pattern. So we can see that this is the basic, the on the left hand side, we can see that all the different UIDs are present. Now onto the different, let us say we are supposed to see this UID. Then we have to just simply click onto the right button, then corresponding image will be displayed. And onto the top, we can see that total 7 images are selected and 0 images are removed. Now, as we scroll, as we move on to the next button, then we can see that this 0098 UID fish is moving, and we can identify the pattern of that fish. Now, let us say, now currently, let us suppose select all the UID. We can see that currently we have total 257 images are selected, and we can also double click onto the particular UID also to 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 see the which UIDs belong to which path. So after this path are created, and this path will be used by our model. Then if model see this kind of path, suppose this is the some long kind of path, then it will be just detected, yeah, this path belong to this UID. Now, after creating this path UID, now onto the database, the marks table will be created. Onto the marks table, it is containing the path image name, marks image name, width, height, and UID of that frame. Now, after creating the marks table, now the second task is to path detection model training. What it is doing is, it is taking our marks dataset, and it is just splitting into the train and valid. As we can see that we have previously 257, total 257 are images are created for the movement path. So from the 257 images, the 50 are going for the test images, and remaining 207 are for the training. Now again 207, we are again splitting into the 177 for training images and 30 for the validation images. So we have generated the training generator and validation generator. There is a logger variable also created. This logger variable will just create a log file which is generated when we are running our model. So model.fit generator, which is just taking the training generator and validation generator to generate our model. Now total currently we have generated 106 classes, means that 106 directory, 106 different unique IDs directory. Now we have found whenever we are running this training generator and validation generator, we have the 177 images belong to 106 classes. All the 106 directory, we are taking one by one images, so that we can sufficiently effectively we can convert split into train and valid. So after splitting, then we are just simply just predict generator. We are passing our validation generator whether it is predicting correctly or not, and also we are passing our testing data set to detect whether it is predicting the correct UID or not. And whenever we are running our model, then it is also storing the log file onto the logs folder, and models into the model folder, and also the classification report of the test valid and the whole model. For the whole model, it is storing into the model underscore report folder. So now let us see the part detection model accuracy, the analysis of the part detection model. So yes, so for the part detection model, the library I have used is the TensorFlow, Keras, Pillow, Scikit-learn, and SciPy. Training directory is Mark's dataset, and optimizer is adaptive moment estimation. Now on the accuracy, at the very first time, I have just passed just the test for the testing purpose, just the 50 images. Now for the 50 images, I have got accuracy 100% and loss is 0.2%. But then I have uploaded more videos and generated the more movement pattern images. So after creating the more movement images, we have got 257 total images. So I have passed all 257 images to the model, and model is trained on it is giving us the 97% accuracy and 7% loss. Now instead of passing all 257 images, now we are splitting into the train, valid, and testing part. So I have passed the 177 for the training data set and 30 images for the validation data set. So for the epoch accuracy, I have got the 98%, and for the loss, I have got the 33%. Now for the accuracy of the validation, it is lays as the 60%, and the 24 is the loss, which is not quite good, because of the we have just 257 different kind of the UIDs are generated. And if we have in future, if we have the more videos, and if we have the more kind of movement pattern, then we can also increase the accuracy. So here we can see that the total 257 images, which is split into 20750 and train and valid. Now to total time taken to train the model is nearly 10 minutes, and accuracy on the valid data is 3%, but accuracy on the test data is not part of the training, which is new for the model. Now for the new photo model, which is the 50 file, and it is detecting the 30% unique ID correctly if we pass some kind of path to the data set. Now this is the accuracy of our model, how we can analyze our path of the model. Here we can see that the different kind of the path. Suppose we have selected the second UID. Now onto the second UID, we can see that these are the path. This are the path is moving, and if the model see that this kind of path is going, then it will be checked that whether this, and if is there any fish which is belonging to this kind of movement, then it will be just assign the correct UID to that fish. So basically, simply the model is just working onto the movement pattern of the fish, and it is analyzing the movement pattern of the each fish and identify the unique ID as per the movement of the fish. So this is the output, and yeah, so our future goal is to train our YOLO model frequently by the reinforcement method. So we don't have to do every time to generate a labeled image dataset, and every time to train again our YOLO model. The model will be do every midnight. Our YOLO model will be run automatically. It will be generate the data set automatically, and it will be just trained by itself. And the second is to train the TensorFlow model frequently with the new video for the prediction of the fish by the fish movement pattern. So currently it is just a fix for the 257 images. Now in the future, if we have upload the new video, then on the daily basis, on the daily we are training our TensorFlow model frequently to identify the movement of the each fish, and we are training our tensor model that yeah, this kind of movement are detected, then you have to select this kind of UUID. So yeah, so this is the my outcome of the future.
Okay, thank you so much for the presentation. And do we have any question? Perhaps Ishika, you can enable your camera again because you didn't.
Yes, sir.
Right. Okay, any question for Ishika? Yeah, Ishika, you need to click. Yeah, and then you will be shown up. All right. So, so first of all, I put a chat message about the website that you can go to do test by yourself. Of course, all of those data they are real data. So, and we collaborate with Australian professor. So you can try, but please don't ruin up or don't destroy anything. And so you can go to fish tracking vipresearch.ca, and then you can see all the functions that Ishika mentioned. Um, while I'm not hearing any, if you have any question, you can unmute your microphone or you can type in the chat. But before I see anything, I would like you to know, I would like to emphasize that Ishika is an undergraduate student at her third years in the university in India, and you can see everything that she presented today actually was done within the last 3 months. So she started to work on this research from June 1st, and now is the September 2nd. So I would like to compliment and thank you, Ishika, for your hard working and everything you've done. As everyone you can see, although at the end we don't have like a very good trace movement recognition. However, you need to remember there are only 257 trace images, and the computer pick up 177 for the training, 30 for the valid when we train the neural networks. And those 177 training image actually are for 106 UUID, which means 106 you can consider fish. So in that case, you can consider only about 1 or 2 trace image belongs to one UUID when we are doing the training. So it's a can predict, can foresee that the result will be not so good. However, the idea is you can consider that in our human being situation, when someone you know walking in front of you, you can tell that is him or her based on his or her movement. That is just like what we are doing right now. Even you have a tank of fish, you probably cannot identify this fish is another fish earlier you saw in another day, right? Unless the fish has some kind of defect or some kind of marks. But if you ask some people, they have a pond or they have a fish tank, sometimes they will tell you, this is John. John is a guy, he is so cute. He always stay here, and when he move through the water, actually he will do some kind of tricks like rotation 360 degree. So actually that is what we want to realize here. If our program can recognize a fish based on their behavior, then every night, every midnight, we retrain, and retrain. You can see that the training process is only about 10 minutes. So even when we have more and more data, we can retrain the model in the midnight, and then we can apply this train model back to the YOLO model to help it recognize more fish. And better, we can actually provide you not the UUID on the bounding box, but now we can provide you a name like Ken, Mary, John, Tom. So we can track a fish, and then you can consider, we can even measure the weight, the size of the fish. So when you are a fisherman or you are a farmer with this ecological environment, actually in the end, we can provide you a history record about this fish when you pull it out and want to eat or want to sell it. Then you can have a QR code which is recording everything we have. So yeah, that is our extremely optimal idea and dream. Okay, anyway, do you have any question for Ishika or for this research? Hearing none, then thank you again, once again, Ishika. Thank you so much for your hard work,
Yeah,
and
sir.
I
Thank
really
you so much.
appreciate that.
Yeah, thank
Yeah.
you so much. Yeah.
Okay. All right.